Hi guys. Okay, so next lesson, factorials and arrangements. Now, I'll get to factorials in a second. Let me start with arrangements. When I say arrangements, what I mean is how many ways can we arrange something? Like here, in how many ways can I arrange 6 books on a bookshelf? So let's start with something that, let's start with another example. Imagine I had 4 people, and let's call them, just for the sake of argument, let's call them P, D, T, and A. So these are my 4 people. And imagine I said, let's arrange these people in a row. One here, one here, one here, and one here. Now, how many ways can I arrange them? Well, let's try and work it out. So I've got a Paul at the front. So let's do my P, D, T, A, fine. Then I could do P, D, A, T. Then I could do P, T, D, A, and then, okay, I want to stop. This is taking too long. I need, and surely there is, a faster and better way to do it. So this is how we do it. We say, how many ways, and this kind of follows on nicely from our product principle that we did in the previous lesson. How many ways can I fill this first place here? How many people can go in here? Well, there are 4 people. I can put 4 people in here. Now, once I've someone in there, he can't go into this one because he's already here. So now, how many are left here? Well, there's 3. There's 3 people left that can go into this. So I do 4 times 3 because of my product principle. So I'm going to do 4 can go here and 3 here, and then there'll be 2 left can go here, and then there'll be only 1 left can go here. So the answer to the number of ways I can arrange these people is actually 4 times 3 is 12 times 2 is 24. There are 24 ways to arrange these people. Now this 4 times 3 times 2 times 1 is a factorial. Now here I've written this question, what is a factorial? This is not a typo, this is actually a little pun. This is the symbol for factorial. So 4 factorial, what that actually means is, it means 4 times 3 times 2 times 1, which is 24. 5 factorial is 5 times 4 times 3 times 2 times 1. 10 factorial is 10 times 9 times 8 all the way down to 1. An interesting one that I'm not going to get into in this video here is 0 factorial, and that's actually 1. One way to think of it is, how many ways can you arrange 0 people? Well, there's only one way to arrange them. This is kind of, it fits nicely into the TOK question, is mathematics discovered or invented? Because we kind of invented this to make it fit certain rules that we have. Okay, but factorials get big, and they get big very, very quickly, right? So 4 factorial is fine. 5 factorial would be this times 5, which is 120. But 10 factorial is more than 3.5 million. Do the math if you don't believe me. It's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. They get bigger and much bigger than even exponentials. They get crazy big. And one crazy example is 52 factorial. Now, if any of you play cards, you'll know there's 52 cards in a deck. And if you shuffle a deck of cards, it's highly likely that that specific arrangement of cards has never come up in the past and will never come up again. Because, do you know what 52 factorial is? Well, it's more than 8 times 10 to the power of 67. And this number, just to give you some idea of how big this number is, this is more than, I just googled this, 10 to the power of 50, which is what Google says, and I have no reason to doubt him. He says there's approximately 10 to the power of 50 atoms in the world. So and this is a far bigger number than this. So there's far more arrangements that you can make from a deck of cards than there are atoms in the world. Right? Let that sink in. Okay, let's do some examples. In how many ways can I arrange 6 books on a bookshelf? So this is just like this, simple example. The answer is 6 factorial. This is probably the last one I can do in my head. Once it gets to 7 and 8 factorial, it gets complicated. But 6 factorial, well, this is complicated. 5 factorial would be this times 5, which is 120. And then 6 factorial is 120 times 6, which is 720. Now let me show you now how to do this on your calculator. So 6 is here. Factorial, see this book here? This is where you find most things. If I press Control and the book, it brings me to a lot of symbols here. Here's my factorial symbol. Press Enter. 720. Nice. Okay, next question. 9 students and a teacher are queuing. In how many ways can they queue? Right. Part A. That's just assuming there's now 10 people. There are 10 people. How many ways can those 10 people queue? Well, this is 10 factorial. I definitely don't know how to do that in my head, but I told you already that is a big, big number. 10 factorial is 3628800. 3628800. That's, look, that is more than 3.5 million, which I said. So that's how many ways. If you only have 10 people, that's how many different arrangements you can make in a queue. That's incredible. Okay, part B. In how many ways can they queue if the teacher has to be in the front? Okay, imagine the teacher's at the front, and then there's 9 other kids here. So the teacher doesn't change anything. He's staying there. All you have to do is look at how many arrangements of the kids there are, and that's 9 factorial. And 9 factorial is oh yeah, it's just this divided by 10. Let's think about it. 9 factorial times 10 gives you 10 factorial. So it's just 36288. Fine. In how many ways can they queue? In how many ways can they queue if the teacher has to be at the front or the back? Okay, so now the teacher can be at the front. That's this, 9 factorial. Or he can be at the back. So it's actually this times 2, because there's 2. He can be at the front, that's 9 factorial. And then he can be at the back, that's 9 factorial. So it's this, this times 2, or 9 factorial plus 9 factorial, which is obviously the same thing. And that gives me, let's just do times 2. 725760. 725760. Fine. Last question. In how many ways can they queue if the teacher cannot be at the front or back? Okay, there's 2 ways to do this. I put this question in deliberately because I want you to do it this way. I wanted you to have an example of this way, where you actually subtract what you don't want from the total. So the total, there's 10 factorial ways in total. And he says, in how many ways can they queue if the teacher cannot be at the front or the back? So this is what we cannot have. This is what we don't want. So I need to subtract 2 times 9 factorial. And that gives me, well, it is 10 factorial. 10 factorial minus 2 times 9 factorial. 2903040. 2903040. 2903040. Fine. The other way I just wanted you to think about doing it is, you could put the teacher second and then do 9 factorial, then put him third, 9 factorial, fourth, 9 factorial, fifth, 9 factorial, and even 10th, 9 factorial. So there is 9. If you do 9 times 9 factorial, you should get the same answer, because this is like looking at the 9 different ways you could put the teacher when he's not at the front of the back. So second, third, fourth, second to 10th basically. Press enter. Darn, that's a different answer. Sorry, there's not 9 ways, there's 8 ways. What am I doing? 10 minus 2 is 8. So it's 8 times 9 factorial. And there you see, this answer is the same as this answer. Okay, last question. Well, there's 3 parts. In a class of 15 students, there are 6 boys and 9 girls. They are lining up in 2 rows for a photograph. In how many ways can they be arranged? Right, this is just, there's 15 students, this is 15 factorial equals, I'm not even going to write it down. Do it on your calculator, write down the answer. It's going to be big. Well, look, let's do it. Let's just at least see how big it is. 15 factorial. There you go. Right, let's write it down. 130767, 130767, 130767, 4368000, 4368000. That's a lot of ways to arrange 6 boys and 9 girls. Right. Part B. In how many ways can they be arranged if the boys have to be at the back, in the back row, and the girls have to be in the front row? So what we do is we say, how many ways can the boys be arranged? Well, the boys can be arranged 6 factorial. And how many ways can the girls be arranged? 9 factorial. So we have to do 6 factorial times 9 factorial, because we're going to do, the boys are all being arranged at the back, and then for every arrangement that you have of the boys at the back, you have 9 factorial ways to arrange the girls at the front. So look, again, a lot of ways, but it won't be as big as this. 6 factorial times 9 factorial. Okay, 26127, 26127, 26127, 3600, 3600. Fine. B and then C. Last one. In how many ways can they be arranged if the boys and girls have to be in different rows? Okay, so that's just a little, this is like a little trick at the end. This one, the boys had to be at the back and the girls had to be at the front. Here, you could have the boys at the back and the girls at the front, or the girls at the back and the boys at the front. So that is just simply this times 2. So it's 6 factorial times 9 factorial times 2, because there's 2 different ways. Either the boys are at the back or the boys are at the front. And this is equal to times 2 times 2, 52254, 52254, 52254, 7200, 7200. Okay, so that's an introduction to factorials and arrangements. There is plenty more of this coming. As I've said in the previous lesson, it gets worse, and it gets even worse than this. But it's fine. Don't be too stressed about it. It's fun, as I said in the past. Okay, that's factorials and arrangements. I'll see you in the next lesson where we're doing the algebra of factorials.